Alright, ladies and gentlemen, in this video we are going to look into parallel, skew, and coincident lines. And we've already defined parallel and skew lines. Our parallel lines are lines that are on the same plane and never intersect. And our skew lines are lines that also never intersect, but they are on different planes. So we're going to kind of be focusing on this first criteria here and defining those two. We've already kind of talked about, like I said, parallel and skew lines, but we're also going to look into an example of how can we identify those two, or those four different types, of lines in a diagram. So let's take a look here at the diagram that we have. So if we take a look at this diagram and it says work with a partner, today I'm going to be your partner as we kind of work here through this example. What our goal is to identify these pairs that we have on the left-hand side, and we're going to prove if, or classify, I shouldn't say prove, I should say classify them if they are going to be skew or intersecting or parallel, or what we call coincident. Coincident is a new term for us. Coincident just simply means two lines or shapes that lie on top of one another, okay? So let's first and foremost see what we got here. For this, and I'm going to kind of explain the reasoning, I guess, out loud versus writing all of them on out. So let's take a look here at AB and BC. So AB and BC are right here. And so what would we consider those? Well, those two lines, they obviously are going to intersect. So those are just simply put intersecting lines. So those are just intersecting lines. So why are they intersecting? Well, specifically, they are intersecting because they share that point B. Let's take a look at our next pair at AD and BC. AD and BC. Well, the key takeaway here is obviously that they do not intersect, but specifically speaking, all right, they are on the same plane. So AD and BC would be considered parallel because they are on the same plane and don't intersect. What about down here? It says EI, but remember, EI, the line, is the entire line. It just happens to include E and I, but also H. So EIH are all on the same line. IH is the same line as we go on over those. That's an example of a coincident line, coincident lines. Let's take a look at BF and EH. So we have BF right back in here, and we have EH back here. So BF is a vertical, but kind of towards here in the back of our prism. EH is a horizontal on this front face of our prism. And so if you continue and imagine that these lines go up and down forever, and here out and out forever, those are never going to intersect. But they also lie on different planes. So those are an example of skew lines right here, skew lines. What about EF and CG? So EF right here and CG, this line here. Well, this is very similar to our same example that we just did. Different planes, never going to intersect. So those would be skew as well. And then let's take a look here. AB and GH. AB and GH. Well, one might immediately think that these are skew lines, but be careful. If you remember correctly, back from our discussion of our three-point postulate, our three-point postulate says that through any three non-collinear points exists exactly one plane. So technically, this is a little tricky here, technically, I could say that there is a plane of ABH or ABG or GHB. I could say that's a plane, and if this is the same plane, then AB and GH would technically be parallel lines. So it's kind of a tricky one there, so keep that in mind when you're asked about things in regards to a diagonal.